Doesn't matter que es 11 and 2, the coefficients, you know, it's not important. It's not important. 11 and 2. It's a hyperbola. It's the clue. Okay, so now, as always, this is the general form. I need to express in standard because I want to see more clear this hyperbola, no? So I see que this is x, and this is x, and this is y, and this is y.
Creo que me estás tratando de pedir algo. Por favor, barajéamelo más despacio.
Now you put together 11x squared plus 66x plus something que I don't know to complete the square. Minus 2y squared minus 4y plus something. And also you put 75 negative in the right hand side plus 2 something. Okay, there's something that we need to complete the square. But to complete the square, you need always get the coefficients in front of the square must be 1. So you factor out 11. You copy x squared plus 6x plus the box. Of course, this box is not the same of this box because this box is already factored out 11, no? Okay, but entonces this is something, que is the number here, multiplied by 11 is the number here. But I don't care. Minus 2 is the common factor, entonces we have y squared plus 2y plus box equal minus 75 plus 2 boxes. It's obvious that the magic number in the first is 9. Yes or no? Do you understand where I come from 9? Yes or no? Do you understand? Come on. Yes or no? Yes, right? And the number in the y part is what? Do you understand where I come from 9 and 1? Now this 9 that you introduce artificially to complete the square actually is 99. Because 9 times 11 is 99. And this one that you introduce artificially is no 1, is negative 2. Because you multiply by negative 2. Okay, easy. Entonces now the factorization is 11, x plus 3 squared, minus 2, y plus 1 squared equal, and let me try to compute that part. That part, 75 negative, and negative 2 is negative 77. Subtracting 99 is obvious 22. Everyone following so far? Answer, yes. Glad you say yes. Now finally remember. Okay, remember. In a standard, right hand side must be 1. You divide by 22 both sides. You divide by 22 both sides. You divide by 22 both sides. So we have x plus 3 squared over 2, because 22 divided by 11 is 2, minus, okay, minus y plus 1 squared over 11 equal 1. Nice, standard, super nice equation que algebraically is equivalent 100% to this ugly original equation que nobody understands. Okay, the only thing that we are doing is some smart transformation, but it's equivalent 100% algebraically, no? And you determine that the center of this hyperbola is located at the point minus 3, minus 1, no? Is obviously que es horizontal hyperbola because the positive part is associated with the x part. So it looks like that. Bam, bam. No like that. Bam, bam. No. And a is radical 2 because a squared is 2, no? and b squared is 11, no? 11, entonces b is radical 11. Okay, when you have an irrational number, you compute the decimal approximation in your own calculator. This is 1.41, this is 3.316, and c is square root a squared plus b squared is the formula in the hyperbola, ¿no? Entonces 2 plus 11 is 13. The c is square root 13, que is approximately 3.605. And the rest is easy. The rest you go to the decimals. Okay, I want to skip that part. I suppose you practice a little bit or no? Not yet. With the using the link I sent to you last time of decimal. You at least you open, no? Yes or no? Let me know. Let me know. You open or no? By checking it out. Check it out. What means checking out? Checking it out. I don't understand what it takes. Check it out. You need to check. Okay. So last time, if you want, I send again when I send the video of this. I send one more time the link to open decimal. It's a script que I create que es super fantastic. You typing on this everything you need and the test and the everything, and you verify the points in the graph. Cool? Okay, let's move on to the next section, que es super easy. It's about sequences. Sequence, M. Sequence. Sequence is very using in mathematics and calculus. And sequence, we can interpretation like a function. And that function, the domain, always is a natural number. This fancy capital M represent natural number, and the natural number are, guys, 1, 2, 3, bam, and continue forever to infinity, no? No zero, no including zero. Zero is the whole numbers, and no negative. It's a natural number, and the range is a real number. Entonces now, to represent sequence, you're using one thing is called explicit formula. Explicit formula of the sequence. And normally the letter that we use, I don't know why, it's A sub m. A sub m represents the m terms of the sequence. I suppose one example to understand, no to blah blah blah. You have m minus 1 divided by m. It's giving this equation, this explicit formula. Entonces now classical example is, well, give me, can compute the five first element in the sequence. Okay, let's do it. So A1, you declare que n is 1, is 0, because 1 minus 1 divided by 1 is obviously 0. A2, you replace n for 2, 2 minus 1 over 2. This is 1/2, and so on. A3 is 3 minus 1 over 3 is 2/3. And we can predict without computation because the numerator is 1 less than the denominator. So A4 is 4/3. 3 over 4, sorry. So n is a coincident, this n is coincident with this. And the top part, numerator, is subtracting 1. A to the 5th is 5 over 4. And so on. What is the A to the 6th? Is 6 over 5. Okay, easy. I said the first example. Example 1, to understand what is the sequence. It's a function. Always is given, or not always, but some frequently is given the explicit formula. Suppose now, another example. Suppose this sequence a sub m is equal -1 raised to the m power 1 over m. Again, we try to find the phi first element in the sequence. So basically, I need to find A1, A2, wow, A3, A4, A5, and why no A6? So not 5, 6. 6 first. Okay, there you go. You replace mentally M for M. M for the corresponding number, no? The -1, the first one is -1 to the first power times 1 over 1. -1 to the first power is -1, 1 divided by 1 is 1, so the answer is -1. And this is important, pay attention. Pay attention, this element. Okay, this element produce alternating sign. Negative, the next is positive, the next is negative. This is called alternating. Alternating what? Alternating sequence. When you see in one sequence this term or similar to this, because no, it's always says like that. It's because the sequence is alternating. Entonces, en the second, it's obvious when you raise -1 square positive, it's 1/2, because in that part n is 2. And the next is negative, alternating, 1/3. And the next is alternating, it's positive 1 over 4, negative 1/5, and positive 1 over 6. So the even guys is positive, and the odd guy are negative. But not always necessarily the same. Suppose que I create one example 3, very similar to this, in which you change one detail. You change a sub m is -1 raised to the m plus 1 multiplication by 1 over m. It's exactly the same, except when you create n plus 1, now we get the same number, but the sign change. A1, A2, A3. Let me try to understand A1 at least. A1 is -1 raised to the 1 plus 1 is 2. Wow, positive. 1 over 1. Entonces it's 1 positive. You see the difference? And likewise, the second no, because it's 2 plus 1 is 3. -1 to the third power is a -1. There's -1 half. This is positive 1/3. You know, get the positive never necessary to indicate. I delete that. A4, A5, A6. So this is -1 over 4. This is positive 1/5, and this is -1 over 6. Do you understand the idea? Clear or confused? It's easy. Hello, this is nothing for us. Okay, let's switch in now to another topic important, que es summation notation. Summation notation. Summation notation, guys, we need to use it in calculus. Calculus 1. Let me go to the restroom now. I'm back. Summation notation. Summation notation is a fantastic way to condense in one long summation. Suppose you have A1 plus A2 plus A3 plus These 3 points indicate continue, not forever, sino que continue in the same pattern. So the next is 4, 5, 6. Suppose que you ending bang in A20. Too long. However, we can condense it in that way. You put this letter. Okay, by the way, this letter is Greek letter. Okay, call it sigma, capital sigma. Is the name of this, capital sigma. And this indicates summation of the same element I call A sub k, because we declare k like index variable. Okay, entonces k vary from 1, k equal 1, to k equal 20. Now, how you indicate that? When you put k equal 1 in the bottom, get the first initial, and k equal 20. I don't know why. Some book, yes, but the majority of book put 20 because you default. You understand that we are talking about the index variable k. So this short way expresses the same long way of this. And suppose que es 200 or 500, and you declare in this compact way, super easy. Let me see one elementary example. Suppose que I have summation notation sigma from k equal 1 to 5. Oh, so we have 5 terms of the one expression is 1 over k, reciprocal. So you evaluate one by one. 1, 2, 3, 4, 5. For 1 is 1 over 1, que obviously is 1. The second is 1 over 2. The third is 1 over 3. And the next is 1 over 4. And the last one is 1 over 5. And stop. Stop. This is equivalent. Everyone in the world understands that this notation is equivalent to this. Okay. I bring another example. This part is easy. Every student understands very well. Except the student is not coming to the lecture, no? You know. Suppose let's do it backward. Suppose I put 1 square plus 2 square plus 3 square plus 4 square. Entonces plus dot. I suppose que negative 5 squares and so on, no? And the last guy is 9 square. And you express it in summation notation. So you declare one variable. Normally the name of the variable we're using in that part is k, is n, is I, or j. Either way, I call in my paper m from n equal 1, can represent this, to 9. Okay, this. Of what expression? K squared. You put the same in this variable. Sorry, no k, it's m. You put the same variable that you declare here, you put here. And this is the condensing way to express this long summation. Cool? Everyone follow me so far? Now, let's see application of this. Fantastic application for the summation notation. Therefore, we need to study several properties. It's a property of summation notation. Okay, let's do it. Okay. Property number 1, which is elementary. Suppose you have summation from k equal 1 to m of one expression. Inside the expression we have, you know, any formula a sub k, pero multiplication by c, times c. This is the argument of the summation. What should I do? Well, you can put outside the constant c. C is a constant, it's a real number. Summation k equal 1 to m of the a sub k. I have one more clear example to understand this. Suppose we have example about property 1. No? Is suppose we have summation from k equal 1 to 20 of the 5k squared. Well, when you face the computation of this 5 is a constant you put outside like a common factor. You factor out. It's a classic. And you dedicate to compute this part first, in the formula that we studied in a few minutes, and after multiplication by 5. That's it. That's it. Because the summation notation working like a linear operator. I want to explain what is linear operator. Suppose we have summation k1. Guys, we're using this property all the time from now. Suppose you have plus or minus bk. I put plus or minus because it's valid for addition or subtraction. You can separate into summation. With the corresponding sign. This is another letter we use. A sub k, A sub m, and B sub m. Normally it's equal A sub m and B sub m. Or C sub m maybe. Another special case. Now this is a linear operator. So basically, linear operator is an operator. Okay, don't care. Okay, you are adding or subtracting or you multiply by coefficients. And you manipulate exactly the same. The constant you put outside like a common factor and you can separate and compute it separately. You compute this, you compute that, and finally addition or subtraction depending on the sign gets connected. Okay. Let me see property number 3, que es very, very important. Very, very, very important. Summation from k1 to m of a sub k. And this property talking about, okay, you can split because you need, maybe you don't see clear now, but in the example I promise, okay, we see the idea, you split this summation into summation. Entonces now one summation is starting 1, exactly the same here, 1. But you taking m, okay, m is intermediate value, m is intermediate value between 1 and m. Suppose que n is 500, and you want to split the summation in 2 summation or in 3 summation. And you go, for example, from 1 to 200, the first summation, because I take m like a 200, and after you continue the summation from m plus 1, que is the next guy, so you stop the first summation in 200, and start new summation in 201 to m. Okay, this is important. Example, a particular special example to understand this property. Suppose you have summation from k equal 1 to 100, and now you split because you want or you need from k1 to 80 plus the second summation is from k equal 81 to 100, the same argument. Okay, maybe you ask by yourself what is the importance of this. Let's see. I promise you see the application. And the example I bring a lot of today. Property number 3, Now property number 4. Property number 4 is fantastic. Suppose you have summation from K1 to M. And inside the summation, you put a constant C. Well, the formula is easy. It's just multiplication because actually this is C plus C plus C plus C, anytime, n times. N times. Therefore, the formula is n times C. So when you see inside the summation, not exactly always happen, but you have complicated expression, and this complicated expression in one part contain the constant. And when you separate in the different summation, you need to know okay, this is the answer of that part is just multiplication that number times this number. And end the story. Suppose example to understand it. Summation from k equal 1 to 5 of 20. It's a constant. Wow. And the professor say you multiply 20 times 5. Oh yes, because the answer is 20 plus 20 plus 20 plus 20 plus 20 5 times, no? 1, 2, 3, 4, 5. Es obvio que es 100. Que es exactly the same. You don't need to expand. No. I did that to prove this idea. But actually, in the real life, you multiplication this and this using that formula. Cool? Okay. Property number 5. Extremely important. Summation from k equal 1 to m of k. Oh, this is different because k is a variable. No, it's like this, it's 20 plus 20 plus 20. No. This is 1 plus 2 plus 3 plus and ending in m. It's the summation of the first m natural number, right? Entonces the formula I give you, if I want to prove in your moment, I don't know si now or Monday, is this m plus 1 divided by 2. This is a formula to find the summation of the first natural number, no? 1, 2, 3, 4, 1 plus 3, 1 plus 2 plus 3 plus 4 plus 5. Suppose I hear one story, I don't know if it's true or not. The one genius in the elementary school, some people say gets goes the same goals of the matrix, no? Que in the teacher in the elementary school to what's the time say, you know, adding the first number from 1 to 100, and this genius doing in 2 seconds. Entonces the majority of the students say no, 1 plus 2 is 3, 3 plus 2 is 5, plus the 4 is 9. I spend a lot of time doing this. However, see, you are doing in different way. Look, let me show you how. You are in the first and the last. Okay, 100, huh? 101. You adding this and this, okay, it's 99. Again, it's 101, right? And of course, the previous of the 99 and 98, and you adding this is 101. Then we can select 50 couple of the number, 50 couple, 50 pairs, 50 pairs, multiplication by 101, okay, by the way is 550, and the genius are doing this in 1 second. And this is the same idea of the formula. The formula is, look, you increasing m, que no necessarily 100, it's any number, 1 million, plus 1, que is for a specific example of the 100, this is 100, this is 101 divided by 2. So the interpretation is 100, and we have 50 couple, que is 100 divided by 2. Do you see that? This is one elementary, no formal proof. of this. I promise again, after we study one super fantastic mathematical tools to allow us to prove everything. No, not everything, but almost everything. Property number 6 in calculus. We're using that. A summation from K1 to M of the K square. Basically, it's 1 square, 2 square, 3 square, and so on, bam, 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 to M square. So it's the same idea, but you raise to the second power everything inside the summation. And the formula is different. In your moment, I want to prove, but no now. The formula is you multiply in the top M times M plus 1 times 2M plus 1 and divided by 6. And the property number 7 is the same summation, but cubic. Cubic, K cubic. Okay, it's 1 cubic, 2 cubic, and so on, 3 cubic to the N cubic. And the formula unbelievable, but it's similar to when the power is 1 per square. I don't understand the reason, but it's proof, perfect proof by the tool guy explained this divided by 4. Or you can write like that, M plus 1 over 2 squared. So it's easy to remember because it's the same formula of this per square. Okay. Okay, so let's see example. To consolidate and understand much better this property. Wow. Too much. Example 1. Example 1. Example 1 is summation from K equal 1 to 5 of the 3K. This is the argument. You can put in the between parentheses or no. This is not strictly necessary. Entonces now you apply the property number. The property number 1, I guess so, no? Oh yes, property number 1. You see the constant you can put outside. To say this is equivalent to say 3 times summation K1 to 5 of K, no? Okay, cool. So now, suppose I want to apply the property we saw before, and this is the property number 5. So we're using property number 1 here. Property number 1 here. And now we're using property number 5. And property number 5, the professor explained, you using that formula. Let me copy the formula here. Summation K1 to M of K is equal M plus 1 divided by 2. And our specific example, N5. So it's 3 times multiplication, 5 times 6 over 2. Where come from this 5? N5. 5 plus 1 is 6. This is 30 divided by 2, 15 times 3, 45. Boom. Entonces, bueno, professor, we can do different. Of course we can. We can do different. One different, like, you know, like elementary school guys that don't know that formula and that property, we can expand this summation like that. Look, summation from K1 to 5 of the 3K is plugging in 1 is 3. 3 times 1, no? 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4, no? Plus 3 times 5. This is 15, this is 12, this is 9, this is 6, and this is 3. And you adding everything together, the answer is 45. Okay, you say, oh, I understand much better this. I don't need to memorize formula. Okay, but suppose I change the problem, I put it here, 500. You are in big trouble, so you are doing it that way. Just say consuming time, too long problem, a stupid problem, and you solve it in 5 seconds using the formula. Clear? Clear? Jenny. Now, example 2, I want to modify a little bit. Okay, it's summation from k equal 1 to 20 of the expression k 5k plus 3. Ooh, you apply several properties. You apply the property number 1 and property number 2 because I want to split this into summation. And the first summation, I have 5k, but I put a 5 outside like a common factor. From 1 to 20. In the second, it's the same limit. Lower limit, upper limit is 20. And we have 3 here. So now I see again the first summation, we have variable k. Now we're using one more time the formula. The formula is 5, 20 times 21 divided by 2. Do you follow me? Where come from 20 and 21? In the second, oh, it's a constant, no variable. Now multiplication is 20 times 3. The answer of this is 1050. And the answer of this is obviously 60, and together is 1110. Do you follow me, guys? Or you are totally lost? Now let me check attendance one more time. Lost, Andres, my darling, Kylie. Okay, Brianna, Natalie. Okay. Okay. I suppose that today, I know very well your name, guys, and you're great. It's the student that want to, so the class is weird. The class is split in 2 parts. The student can get A, and the student can get D or F. And don't do anything. I say big bunch of lazy. Okay, you are in the first class. Andres, Maidali, Kylie, Brianna, Natalie, Rachel, Joshua, Chelsea, Faisal. I don't care. So you don't know, 0 for you. And you repeat and you pay your money again. This is university. It's not high school. Okay. Do you understand very well example 2? Let's do example 3. Example 3 now. Example 3 is a little bit different. Any example I create, bring me new situation. And you need to face that situation using the property of imagination or common sense. Suppose summation from k0 to 14, and expression is k squared minus 4. Okay. Okay, what's the new situation that brings me this problem? Okay, any summation that we studied before in the property, starting 1 to m, or n14, of course. But this is the new thing, okay, starting 1. So you need to do something in order to modification, because before apply the property is valid under the consideration que K starts, o sea, the starting index variable es 1, no 0. But it's easy modification because I separate 0 independent. You plug in 0 here. It's a 0 square minus 4, sorry. Plus, now we have summation from K1 to 14 of K squared minus 4. Do you understand this idea? This was only for K equals 0. And this is only for K greater than 0. So 1, 2, 3, 4, 5 until 14. So I separate 0. Repeat the idea because the formulas of the property no include 0. And when you see 0, outside. Es obvio que that part is negative 4. That part is negative 4. But that part, I split into summation. The first summation starting 1 to 14 of K squared. Minus another summation. Starting 1 again to 14 or 4. Or whatever. You put positive here, negative here, doesn't matter. It's the same. Okay, so now I want to recall one more time the property for that part. Okay, it's a little bit different, no? It's a little bit different. Let me. By coincidence, I suppose que here. Look at that. Look at that. It's a coincidence. It's here. That is a formula. When the variable inside the summation is a square. Look at that. Yeah. When it's a square, the formula is, wow, m plus 1 to m plus 1 divided by 6. So far, we have minus 4 plus something, and now ready to apply the formula. Who is m? M by plus 14. Multiplication by 15. Where come from 15? 14 plus 1. This is 14. This is 15. And this is 29, no? Because 14 times 2 is 28 plus 1 is 29. Divided by 6. Minus, remember this is negative 4, multiplication in this case a constant is 4 times 14. Okay, the rest is arithmetic, stupid arithmetic, negative 4 plus the multiplication, this is 1015 minus 56. Yeah, and now we combine like term is 955. Get the finals. You follow me, guys? Be careful. You need to know every property. Well, you don't need to memorize. You copy the formula you have in your notebook, and you need to select the formula que apply in a specific example, no? That's it. Okay, any question in the problem number, in the example number 3? Is complicated or no? 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 Okay. We can continue doing example 4. Yeah. Okay. And the environment of the co-working and mathematical teachers say this topic is the easiest topic in mathematics sequence. Okay, I respect this. Okay, look, so suppose I want to bring me totally new situation. K equal 10 to 60 of the 2K. Okay, let's do it. First of all, I can see que 2 is a constant, I put outside. But the complication is now that we have one summation que start knowing one. And the formulas that we have in my hand to compute this start in 1. That is a reason that we need to modify this. So you modify this summation. Well, let me copy the basic idea for the transformation, but down to understand this. We have, for example, I know that the summation of something, I don't care, something, from k equal 1 to 60, we can split like that from k equal 1 to to 10. Why not? To 10 is possible. Or to 9, to 9, to 9, to 9, to 9. Why 9, Professor? Because 9 is, okay, is from k equals 60, is from k equal 10, 10, 10, 10. Okay, let me explain another way. Look. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, 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 60. I need the summation from 10 to 60. It's the thing I need. Look at that. I need that. But the formulas that we have in my hand start in 1. Therefore, I propose this strategy. You adding from 1 to 60 and subtracting the 1 to 9. Make sense? So you adding, okay, okay. So now, let me try to understand more clear now in mathematical language. So one summation from 10 to 60, we break it down into summation. One summation can go from 1 to 60, get the red part. Of course, minus subtraction. One summation gets the blue part, que start in 1 again to 9. Make sense? I omit the argument, but intentionally, because this is not the thing I try to think. So now you have 2 factor 2 that was at the beginning. I did that big bracket, and you break it down this into summation. The summation of kk and this both go from 1 to 60, and this is summation go from 1 to 9. So now it's super easy because I apply a formula. The formula, I repeat this idea, you can apply when the k value start in 1, no in 10, no. In 10 you need to split and subtracting something. There are many ways to understand this. Let me know if you understand this or not. You understand or no? No, because I explain in the class in person. I explain this. Yeah, you see the face of the student is weird. Oh. Do you understand or no? I explain in different way. Yes or no?
Yes.
Okay. Now ready. You are ready to finish this problem. And the formula that we are using, you know, is the famous formula n plus 1 divided by 2, no? Because this is k, no k squared, no cubing. It's easy. Entonces 2 times what? 2 times 60 times 61 divided by 2. Minus m is 9 times 10 divided by 2. Well, actually, if you want, you cancel out these two, because actually it's a common factor that 1/2, and 2 divided by 2 is 1. So multiplication 60 times 61 minus 9 times 10, que es 90, ¿no? Entonces basically we have that part is 3,660 minus 90 is 3,507. It's finals. Okay, so we have different options, different variants to manipulate the summation notation. The formulas we start at the beginning, I repeat again several times, is valid only when you start N1. Otherwise, no. Otherwise, no. Example 5. Example 5 is similar. Is when you see that, wow, be careful, caution. Summation from k equal 4, oh, start not in 1, start in 4, to 24 of k cubic. K cubic, remember we're using the last formula. Okay, the last formula, the summation, let me copy, is from k1 to m of k cubic is equal is m plus 1 divided by 2, but everything is square. Okay, entonces now this is impossible. Apply the formula because the formula is valid when you start in 1, not in 4. However, you split the summation in two summations. Of course, with the same argument, que es k cubic. K cubic. The first one started from k1 to 24, and you need to subtracting the part that you don't want. Okay, the part that you don't want is starting 1 and ending in 3. Where come from this 3 is 1 less than 4. Okay? Do you understand this, or I need to do the diagram again to understand this? You have 1, 2, 3, 4, 5, 6, 7, bam, 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 to 24. I need this part. Include 4 to 24. However, we have no formula for this. However, we have the formula for this. And for this. But let me use another color. Blue. Entonces, this is the red summation, and this is the blue summation. And give me the green summation. And the rest is apply the formula and end the story. The formula is super easy. Is 24 times 25 divided by 2 is squared. Minus 3 times 4 divided by 2 is squared. This is 90,000 minus 36. See, because 3 times 4 is 12 divided by 2 is 6. 6 is squared 36. Now the final answer is 89,964. Everyone follow me? Cool. Cool. Super. Now, let me erase the board. I can't do that. Erase the board. Okay, I can't do that. Okay, entonces, application of this. We have two fundamental, guys, sequence and mathematics. Arithmetic sequence. Arithmetic sequence. And geometric sequence. But forget about geometry for a moment. We focus on arithmetic. One classical example. And we study both, no? But first of all, arithmetic. One classical example of the arithmetic sequence is the sequence formed by 4, 6, 8, 10. Bam, 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 bam. I need to 3 periods enough to understand that this is continuous forever. Okay, so one, important Idea is determine the explicit formula for this sequence. I don't know. And when you have that, you will be able to determine any element inside the sequence. Entonces, what is the idea? How you identify que es arithmetic sequence? When you find you subtraction, 6 minus 4 is 2. 6 minus 8 is 2. 10 minus 8 is 2. And 2 is the common differences. Common differences. Okay. So you subtract the S2 and you subtract the S3, no, it's not arithmetic. So when they exist the common difference, this sequence is arithmetic. And arithmetic, they are a formula to find A sub n explicit term. Okay, it's equal A sub 1 plus n minus 1 times D. This is the most important formula today. Let me identification, who is that? A1 is the first guy. In our example, A4, because I suppose que es n equal 1, n equal 2, n equal 3, n equal 4, and so on, no? And D, I investigate que es 2, no? Entonces, plugging in. Just the A sub n, the explicit formula for the m element, either any, is equal 4 plus something, A1 and 4, parenthesis n minus 1 times 2. Leave it like that? No, hello. You apply some algebra. You apply distributive to n minus 2. Entonces A sub n is equal to n plus 6. No, plus 2, no? Because 4 minus 2 is 2. This is the formula. Okay, identification, any. Let me verify. Not all of them, but at least one. Suppose n equal 4. N equal 4. Plugging in is a to the 4 power. A to the 4 power, no. A to the 4 term is 2 times 4 plus 2. 2 times 4 is 8. 8 plus 2 is 10. Wow, exactly. You have here, right? N equal 4 is 10. Do you see that? Straightforward, eh? Okay, let's practice example of the arithmetic sequence. Arithmetic sequence. Okay, suppose the example 2 about arithmetic sequence. Okay, is suppose 2, 6, 10, 14, 18, and so on, infinity. You need to find the explicit formula for the n e specific I1 in the position 41. So I complemented the example with the you find for the any value, and now you want to find what the specific 41. Okay. So yeah, I remember the formula A sub n in general is the first plus a minus 1 d. Oh, entonces I need to find the common difference. Bueno, este for the thing you should do before this. Because if there are no common difference, it's not arithmetic, and this formula is invalid. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is 4. Oh, this is D. This is my common difference. Now the formula, ready. The answer is yes, it is arithmetic sequence. Therefore, I apply the formula. Entonces A1 es 2, que es the first element. A1 is equal to A2 is equal to 6. A3 is equal to 10. A4 is 14. A5 is 18, and so on. Entonces es 2 plus n minus 1 times 4, que es the common difference. Apply distributive property. 2 plus 4n minus 4 is 4m minus 2, no? Like so. This is a formula, and using that formula, we generate everything. Suppose, by curiosity and confirmation, double checking, I want to find a sub 5, que I know que es 18. Look at that. Well, entonces 4 times 5, you replace n for 5 minus 2, 20. 20 minus 2 obviously is 18. So you want to find 8 to 41, the only thing you should do is plug in 4 times 41 minus 2. And the answer is 162. Boom. End of story. Super easy. Super easy. Any question, guys? No? Okay. But this is just the beginning. We have more. 2 more. Inside the arithmetic sequence, it's important also to find the summation. So the idea is, I want to erase the board, guys. Okay. Look. Now we dedicate now to find the sum of arithmetic sequence. Okay, what's that? Well, suppose you have summation k equal 1 to m of the a sub k is equal a1, a2, a3. Of course, you continue, but you finish in a sub m. And the formula, this is a little bit long to prove this, but it's doable. Is a1 plus a2 compute the average. It's unbelievable. Look, you take the first, you take the last, adding each other, and divide by 2 gets the average, and multiply by m. Okay, n is the number of elements we have inside the summation. And unbelievable, you obtain the sum of the first n element. Well, one particular example is the summation that you see before, 1 plus 2 plus 3, no? Plus 4 plus blah 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 plus m. Again, this case is a particular example of the arithmetic sequence in which the common difference is 1. Right? And the first is 1, look. The last is m divided by 2 and multiplication by m. And we get exactly the formula that we're using in the property number 4, I guess so. Let me check it in the paper, the property 5. But this is a specific particular cases. And other more complicated. For example, you have this example. Let me call example 3 in the arithmetic sequence. No? We have 60 plus 64. So our problem right now is no determine the value for each element inside the sequence. No. It's doing the summation of the one portion of the sequence. 68 plus, suppose it's given this problem like that. And ending in 120. And you need to find the summation, this sum. Another notation, this is summation notation. Are you familiar? Another possibility is use a capital S sub m. It's the same. You know, this is short. Either way, the way that you prefer. It's completely free. Okay. Entonces, professor, we're using that formula. Okay, nice. Who is A1? No, A1 is 60. It's the first element. Who is A sub n? Oh, A sub n is the last one, the 120. But the problem is that I don't know who is n because it's not given clear. You can continue to expand, and maybe it's too long, it's impossible. No, impossible, no. It's too long. It's too, you spend a lot of time. One fantastic way is using my complementary formula. It is A sub m is equal to A1 plus n minus 1d. Okay, remember this formula is the most important today. Y este formula que state the connection in between any position inside the sequence and the first. So I want to find, I know that this is 120 in our specific problem. This is 60. This is n minus 1. And the common difference is I forgot to find PS4, right? DF4. You're subtracting any element minus the previous, the answer is 4, the answer is 4, the answer is 4, the answer is 4. F4. So you have equation, and the only unknown that we have in this equation is m. Okay, indicate the amount of element that you adding in the summation. Okay, entonces now, so for m, it's easy. One easy way is subtracting 120 minus 60 divided by 4, and this give me n minus 1. 120 minus 60 is 60, divided by 4, 15, is equal to n minus 1, then n is 16. Ooh, my summation contain 16 elements. O sea, this is summation 16 elements. Or another possibility is summation notation is from K1 to 16 of the one expression that I don't know exactly, but I want to find H1, no? But using this. Okay. So now, pero no. I use my specific formula. Que es this. Entonces, the formula is no this. I use the formula. What formula? That formula. Parentheses. 60 plus 120 divided by 2. Multiplication by 16. End the story. Entonces 180 divided by 290 times 16 is 1440. Guys, do you follow me? Look like horrible? Look like confusing? Weird?
No.
No. Cool. So we recap. Basically, it's giving one summation, and you detecting in the middle of the process. Wow, we are talking about arithmetic sequence. It's one piece of the sequence that you add in each other any element. And this is the formula. The formula is super easy to understand. You add in the first and the last, divided by 2, average, and multiply by the number of elements inside. But the number of the element is not given. Sometimes yes, sometimes no. But in this case, no. You need to find using the second formula. So you have two fantastic formulas that combine each other to solve any problem, of course, involving arithmetic sequence. Let's do one more. Let's do one more example. Very, very similar. But of course, I introduce new idea que look like weird, but it's okay. Example 4, no? Example 4 is 4 plus 4.5 plus 5 plus 5.5 plus, what is the next? The next I suppose is 6, no? But I don't care. I don't care too much. I put plus, I put indicate gets repeated using the same pattern, and the last guy in the sequence is 100. You need to find the sum sub m of this. I have a question. What is the common difference, guys? Oh no, where's the first guy? A1. Yeah. Gladys say that the common difference is 0.5. Okay, this is the most complicated. The first one is 4. And the last one is no 2. Is 100. Okay? The first is A4. This is A1. This is A2. This is A3. This is A4. And this is A. I don't know what specific these numbers are. Again, we need to find M. To find the M, well, we use one more time that formula. You put here 100. You put here 4. A minus 1 multiplication by 0.5. Okay, this is the easy way to isolate this is you put 100 minus 4 divided by 0.5 is equal something, is equal 192, I put in the calculator, or divide by 100 by 0.5, sorry, is equivalent to multiply by 2, no? 0.5, get the common ratio. And this is n minus 1, therefore n is 193. Wow, it's too long. There's 193 elements inside the summation. We cannot predict at the beginning this long summation. Now, entonces ready to apply the last formula. Okay, the last formula is easy. Look, you take the first. You take the first, get 4. You add in the last one, get 100, divided by 2, average and between both, and multiply by 193. Because we have 193 elements. Now this is 10,036. And the summation. Cool. Do you understand very well the arithmetic sequence? This is a particular but important case example of the sequence. It's very, very common in the real life. Okay, let me try now geometric sequence. Geometry sequence. Inside the sequence topic, geometry sequence. Geometry sequence. Suppose this example trivial to understand the idea behind geometry sequence. Suppose 2, 4, 16, 64, bam, 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 bam. At the beginning, I don't know. So I believe because geometry, you subtracting 4 minus 2 is 2. 16 minus 4 is 12. Oh, no common difference, no arithmetic. But I make a mistake here. This is 1. This is 1. It's the worst. So 4 minus 1 is 3. 16 is 4. No, not good. And so now, instead of subtracting, we are doing division. Division. You divide. No subtracting, it's division. 4 divided by 1. Always you divide any element divided by previous. It's obvious 4. And 16 divided by 4 is 16 divided by 4 is 4. And 64 divided by 16, 64 divided by 16, again is 4, no? Okay, entonces now we have something in common, pero no common difference, it's common ratio. The word ratio indicates division. The common ratio. Ow. Erase, ratio. Okay, basically you divide any element. Suppose you divide a sub m divided by previous, que es a sub m plus 1. If the ratio, the division is a constant. This constant is called common ratio. And the formula for the geometric sequence, the explicit formula, is a sub m is equal to a sub 1 r n minus 1. This is the formula that allows us to determine this. Well, let's try in this example. No, it's example 1 of the geometric sequence. Now I want to determine the formula because it's not clear for me. Okay, no problem. I understand that A1 is 1 and common ratio, sorry, R is 4. Substitution here. A sub n in any position is equal 1 times 4 to the n minus 1. Multiplication by 1 is nothing, and the formula is 4n minus 1. Let me verify if we are doing well or no. This is n equal 1. This is a sub 1. This is a sub 2. This is a sub 3. This is a sub 4. Suppose a sub 4. Suppose that I want to put a sub 4 using that formula. It's 4 raised to the 4 minus 1. 4 minus 1 is 3. And 4 to the third power is 64. Because of 4 times 4 times 4. Do you understand the idea? Geometric sequence. Example 2. Example 2 is, suppose this 1/2, comma, 1 over 4, comma, 1 over 8, comma, 1 over 16, comma, bam. Entonces in this, I want to find, so investigate if the sequence is geometric or no, and determine the A sub m explicit formula to find any in any position. Entonces now to investigate que es geometry, you divide this divided by this. You divide 1 over 4 divided by 1/2. You copy the top part and you flip it the bottom part. Entonces 2 over 4 que es 1/2. Let's do at least one more. 1 over 8 divided by 1 over 4. 1 over 8 times flip it 4 over 1. 4 over 8. Again, simplification, lowest term, and 1/2. Okay, cool. So the common ratio, I discovered, yes, that's geometry. And you continue if you want to divide this, but no, it's obvious. Common ratio is 1/2. And A1, get the first one, is 1/2 also, no? This is A1, bam, bam, A2, bam, bam, A3, and A4. Now, so what is the formula, specific formula for this example? Well, it's 1/2, it's A1, multiplication by 1/2 raised to the n minus 1. And you leave it like that, you can. Of course you can. However, no. In my opinion, it's better multiplication this and this, no? Entonces, 1 over 2 to the n, no? Because this actually is 1 over 2, que es 1 power. And it's a 1 again, because you know 1 is a magic number, okay? It doesn't matter. The power is stay 1. And when you combine 1 times 1, it's obviously 1. And this time this adding the exponent is 2 to the n. And this is a formula que generate any number. Suppose I pick arbitrary n equal 4. A sub 4 is 1 over 2 to the 4 power. 2 to the 4 power is 16. Bam, it's this guy. Cool? Geometric sequence. Another example, geometric sequence. This is confusing. 10, 9, 81 over 10, 729 over 100. And they want to find, and it's continue, bam, bam, bam. We need to find a sub m. We need to find a sub 9 in the 9th position. Entonces now I investigate if it's geometry or not. To determine if it's geometry or not, you divide, for example, 9 divided by 10. This divided by this. This divided by this. This divided by this. I want to do at least one more. And the rest you suppose is okay. You can check it, no problem. I understand. It's 81 over 10 divided by 9, no? Yeah. It's 81 over 10, and you flip it that, 1 over 9. Okay, use simplification a little bit because I know very well that 81 and 9 times 9. At least this is cancelled. I stay alive, 9 over 10. Oh, it's exactly the same. So now our famous common ratio is 9 over 10. And the first one is 10. Now ready to apply the formula. The formula is A1 Rn minus 1. A sub n is equal 10 times 9 over 10 raised to the n minus 1. You can leave it like that, you can. However, in my opinion, it's better do something here. It's 9 raised to the n minus 1, and this is 10 in the top, and 10 to the n minus 1. And why not the same base? You can subtracting and give me n minus 2. So m 9, sorry, n minus 1 divided by 10, n minus 2. It's one possibility. Or leave it like that. It's not too big deal doing that part. It's no, it's cosmetic. Suppose I want to find a sub 9 and the problem, well, okay, you apply the formula. 9 raised to the 9 minus 1, 10 and 9 minus 2, no? So 9 to the 8 power and 10 to the 7, no? Because it's 9 minus 2 is 7, and you put in the calculator either way. And to say put in decimal 4.304671. Okay, we are ready to understand the geometric sequence and the formula that we're using to find in a position. Now, the most important moment in this lecture is the summation inside the geometric sequence. What is the formula and what is the option we are studying? Look. Now summation. Sum of geometric sequence. Okay. Look. Suppose that we have summation from 1 to m, a sub k, is a1 plus a2, but now element a1, a2, a3 belong to the geometry sequence. Belong to the geometry sequence. Bam, 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 to a sub m. And the formula is different. It's a little bit weird. It's a1, is the first one. 1 minus r raised to the n power divided by 1 minus r. This formula is the summation. We can understand like that. We can understand like that. Summation m. For the geometry sequence, remember in arithmetic is another formula. Of course, you don't need to memorize the stupid formula. No, you don't. And suppose that we have the sequence que we see before, que es 1/2, 1/8, 1/8, no, 1/4, 1/8, and so on. Now, I discover que es geometric when you are doing the division of 1/4. I did before. 1/2 is 1/4, 2/1 is 2/4, que es 1/2. The common ratio is 1/2. And by the way, the first guy is also 1/2. Look, this is A1. Now A sub m is 1/2 and 1/2 to the n minus 1 que I did before, que is 1/2 today. So basically, the thing that we are doing is summation from k equal 1 to m of this particular, que is 1/2 to the n, and specific. So now to simplify and illustrate very well the idea, I want to do easy. I want to do summation from k equal 1 to 3, only 3 elements. Because I want to verification, so, this is 1/2, and this is 1/2, raised to the n minus 1, either way, or you copy the formula, is the same, they are equivalent. And the formula que say is A1, 1 minus r to the m, divided by 1 minus r. In our specific example, A1 is 1/2. In our specific example, common ratio is also 1/2. This is 1 minus 1/2 raised to the third power, because I suppose que es 3, divided by 1 minus 1/2. Okay, now 1/2, let me manipulate here, is 1 minus 1/8. So you are doing the exponential first. 1 to the cubic power is 1, 2 to the cubic power is 8. And subtraction here, you separate, in the order of operation. We can do that, the top part separately to the bottom part. And 1 minus 1/2 is 1/2. Wow, amazing. And it's cancel. And 1 minus 1/2 is obviously 7/8. Do you see that or no? Okay, suppose que you don't see, no problema. You find the LCD, que is 8, 8 minus 1, no? Welcome from this 8, multiplication 8 times 1 is 8, and 8 minus 1 is 7/8. This is the answer que I get using the formula. Pero, okay, I know I am confusing. Let me try to verification, doing by hand. Suppose que you are 1/2 plus 1/4 plus 1/8. There's 3 elements, exactly the same we predicted here, 3 elements. Let me try. LCD is 8. 8 divided by 2/4 times 1/4 plus 8 divided by 4 is 2 times 1 is 2 plus 8 divided by 8 is 1 times 1 is 1. And you add in the top part is 6 plus 1 is 7/8. Do you see that? I put this elementary straightforward example to illustrate the validity of this formula. Okay. Now, this formula is using now to understand another thing inside the geometric, que es series. Let me try to explain, because this is a topic, very important topic in calculus. Calculus 2, series. What is the difference in summation versus series? Oh, the problem is that series is summation, for example, from k equal 1 to infinity. Wow, infinity element. So es, the a sub k would be a1 plus a2 plus a3 plus and continue forever. No es similar to this, que yo stop en one guys que A sub M. No, this is infinity. And then the beauty of that part is, professor, si you adding infinity number, I suppose, using my common sense, que the answer is infinity. Yes or no? You adding infinity number. Suppose que you adding infinity number. Entonces, when this situation happens, this is called the series diverges. Keep in mind this name, que es, or this verb, in this case a verb, que indicate the behavior of the series. However, magically happen case no. Infinity is one number. And where is one number, the action is converge. How is possible that this happen? Let I bring one example to illustrate very, very well this idea using intuition, and after we're using the formula, of course. Suppose this summation, que es 1 plus 1/2 plus 1/4 plus 1/8 plus that infinity now. Okay, we can indicate 1 using that notation, summation from k equal 1 to infinity. Wow, infinity element of the a sub k, I want to express this in the formulas and the explicit formula for the geometry, no? Because actually it's geometry, no? I did before. You divide. If you divide this divided by this, it's 1/2. You divide this by this, it's 1/2. But the common ratio is 1/2. The common ratio is 1/2, and the first element is 1. Okay, there's no formula. Let me use intuition. Intuition now. Intuition. And you help me if you see or not. Suppose I take the rule. And I try to do horizontal line que represent one segment. Now let me see if it's right. Yes. Que represent one segment. Okay. And this is 0. This is 2, I guess so. And this is 1 in the middle. One segment. So you start adding. Is the first guy is 1. When you're adding 1, it's obvious. Let me try to use in color, red color. Que es this segment. It's distant guy, 1. Now, what's the next? 1/2. Well, 1/2, you know, is half of the second segment, is this. And remember, we addition. You see, addition is plus. This distance is half. There is a 1.5. You follow me? You follow me? Now the next guy is 1/4. And 1/4 is a half of the last segment. It's here. Now you include this segment. Entonces 1.5 plus 0.25. This in decimal, this is 0.5. This in decimal is 0.25, ¿no? Entonces this is 1/4. But the summation, I put it down, is 1.75. Do you see that? And the reason is que you adding a segment que is smaller. This is 0.125, que is, again, a half of the last segment here. Okay, so far we have 1.75 plus 0.125 is 100. So that distance so far is 1.875. I suppose que si you continue infinity segment, que anytime are smaller, 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 do you see que es no infinity? Yes or no? Do you see que converge? Do you see que converge? Yes or no? Do you see the intuition? Intuition, no formula. Intuition. Do you see que converge or no? You see or you don't understand?
Yes.
Yes. Yeah, you are adding addition infinity number, but this is number are smaller, smaller, smaller. Not exactly when you study calculus 2 in detail that part. Not necessarily que it's a smaller convergent, but in this specific example I bring to you now, of course, convergent. Convergent to what number you believe. Our opinion. I need to hear opinion. Convergent when you add infinity fraction like that, que following this partner, what's the answer that you expect at the when you ending infinity? 2. A ver, es Jenny, ¿no? Jenny say que es 2. Jenny predict que the answer of this infinity summation is 2. Make sense, guys? Ajá. And the formula que we are using is summation, pero no summation m. Porque summation n ending in one number is summation without so creep, que es, you know, the limit when the n approaches to infinity, so we continue forever, s sub m is equal to s. And the formula is a1, 1 minus r. It's super easy, that formula. The other formula is more complicated. This formula is too easy. But let me explain in detail. We have time. Yeah, we have time. Let me explain. Look, my goal now is discover what is the formula that give me s equal to. But I have no idea. I lost. I know another formula is when there is no infinity. Is, let me copy, s sub m is equal a1, 1 minus r to the n power, close the parenthesis, divided by 1 minus r. Entonces now to investigate what happened with the s. With the s, que es the infinity. So the difference between this and this is que dice summation from k equal 1 to m a sub k. Bam. However, the difference now is series, and series from 1 to infinity a sub k. Okay, entonces now the formula you apply the limits. What mean limit? It's a calculus operator. Don't worry too much. As you suppose que n is infinity, so it's a huge number, 2 million, 3 million, of the s sub n. Entonces now I separate this equation in two pieces like that, minus a1 rn over 1 minus r. And you believe, you suppose que n increasing forever to infinity. If the absolute value of the common ratio is less than 1, so if the common ratio is like the example that we discussed before, que 1/2, if 1/2 is positive, no problema, or absolute value, but it's less than 1, entonces now when you raise one number que es r to the big exponent, this expression, entire expression, go to 0 and stay alive this expression. Now the formula for find s is a1, 1 minus r. A1 to apply directly this formula and this specific example que Jenny using intuitivity discovered que es 2. In other example it's more complicated. to see using intuitive. Now we need the formula. This is the beauty of mathematics, no? The formula discover thing. Now, let me try. Ah, no, not necessary. Look, we have common ratio, a 1/2. I suppose you remember. that the first guy is 1. I'm plugging in. Summation, the infinity is 1 over 1 minus 1/2. Okay, entonces 1 over 1/2 minus 1/2 es 1/2. Reciprocal 1/2 es 2. Boom. And this 2 is this 2. ¿Qué es this 2? Do you see? Do you see? Also, let's practice. Let's practice serious. Yeah, I bring 2 examples to illustrate very well. This is amazing, guys. Pay attention. It's the last part. Look. Suppose que is giving this example. 2 plus 4 over 3 plus 8 over 9 plus infinity. I need to prove first of all que es geometric series. And the challenge is when you find the common ratio, see the common ratio is less than 1, then the conclusion is convergent. Otherwise, diverges. When you find the common ratio, you divide this divided by this. 4/3 divided by 2 is 4/3 times 1/2 is 2/3. Okay, the common ratio. See, you are doing this division. I guarantee you get the same, guys. It's so beautiful. Let's do it. A over 9 divided by 4 over 3. A over 9 times flip it, 3 over 4. Use simplification a little bit, divided by 3, 1, divided by 3, 3, divided by 4, 1, divided by 4, 2. 2/3. Okay, so the common ratio is 2/3. Therefore, 2/3 is less than 1. The conclusion is convergent. Converge to what value? And the formula, A1 over 1 minus 1. Who is A1? 2. It's the first guy, A1. What is the common ratio? 2/3. 1 minus 2/3. Entonces 2 over 1 minus 2/3 is 1/3, no? Because you find the LCD, que es 3 minus 2 is 1. And flip it is 2 times 3 over 1, que es 6. Unbelievable, but the answer is 6. The answer is 6. Do you see the idea? See, you manipulate and the common ratio is not less than 1. The only thing you should do say is diverges. And that's it. And the summation no computed because it's blew up to infinity. End the story. I bring 2 last examples. Suppose this point, 0.6 bar. Do you remember what means this bar? 0.6? Do you remember this or not? Constant, no constant. Constant. Maybe you have the idea, but no, it's the proper word. Constant, it's repeated, Repeated, like that. This is equivalent to say 0.66662 infinity 6. Yes or no? Edward. Es repeated decimal. Okay. My question is, this number is rational or irrational? Rational or irrational? What do you think? What do you remember the definition rational or irrational, or you don't remember? Or refresh your memory? Well, rational is a number that we can express like a fraction, something divided by something. And irrational is a number that we cannot express like a fraction. There are several examples of the irrational, like a 2 pi, you know, get 3.14, 16, 5, and infinity digit non-repeated. Entonces, in this case, the question is, we have infinity, pero repeated. Entonces, now, this idea que es the same, or at least repetition the pattern, porque no necessarily it's like that. You put 0.65. Entonces, 0.65, 65, 65, and 65 forever. This is also repeated. 2 digits, but it's repeated. And this number que is repeated, the same pattern, is rational. And we can express in few seconds in fraction using this idea that we studied before. Okay, so let me try. Let's quickly. Is look 0.6 is equivalent to say 100%. 0.6 plus 0.06 plus 0.006, right? Plus that. If you want to see more clear, you put in fraction 6/10 plus 6/100 plus 6/1000 and so on. Okay, well, so now I try to discover that this is geometry series. A series because it's infinity element. However, so you find the common ratio is 6/100 divided by 6/10. It's 6/100, flip it, 10/6. The 6 is cancelled, and cancel 1, 0. The common ratio is 1/10. The common ratio is 1/10. Okay, so the formula for the summation infinity series is A1 over 1 minus R. Who is A1? It's this. Okay, by the way, we can simplification like a 3/5, no? In lowest term, it's 3/5 divided by 1 minus 1/10, que is the common ratio. And 1 minus 1/10 is obvious que es 9/10. Because 1 is 10/10, no? Minus 1 is 9/10. Now 3/5 times, flip it, 10/9. Simplification divided by 5/1 divided by 5/2. Simplification divided by 3/1 divided by 3 is 3. The answer is 2/3. And it's no surprise, guys. You put in the calculator, in any calculator, you put 2/3 division, and you get 0.666 repeated. Yes or no? That this number is rational because we can express it like a fraction. Make sense? Do you follow me? Cool. What do you think about this? This is weird, very weird. 0.9 repeated. What's the answer of this? 0.9 repeated. Suppose infinity 9, 0.99999, infinity 9. I know, using the same idea, que es rational. So we obtain the fraction, que is equivalent to 0.9 infinity 9 repeated. Well. Entonces now, what do you think? So let me left this for the extra credit. Let me left 2. Find this using the same idea and 0.51. 5 points for this. But I don't want the final answer, no. I want the proof. What is the answer of this and what is the answer for it? 5 extra points in the test number 5. Okay? Okay? Take advantage. So you attach this in the test, yeah, I grade that. que include the extra point, 10 point extra. Plus, remember the 10 point extra doing the homework. And remember, in the written test, the 5 extra point and the subscription for my YouTube channel. Cool? Okay, guys, we gotta go. Have a nice day. We continue Monday. Bye-bye.